Hi everyone, today I'll be talking about 2005 AMC 12A problem 24. Let px equals x minus 1 times x minus 2 times x minus 3. For how many polynomials qx does there exist a polynomial rx of degree 3 such that p of q of x equals p of x times r of x? So we can see at first glance that q of x must have degree 2 because r of x and p of x both have degree 3, so this would have degree 6. And then, so each of the roots would have to have degree 2. So thus q of x would have to have degree 2. And we also see that the roots of p of x are 1, 2, and 3. So in order for this equivalence to be satisfied, for rx to exist, then qx must be a quadratic, um, and it has to map 1, 2, and 3 to 1, 2, and 3. Not necessarily in that order. So yeah, it just has to map each of one of these values to one of the values here. And the number of ways to do that is 3 to the power of 3, because for each value on the left, there's 3 choices for where to put it in the for on the right, and then there's 3 of these. So 3 to the power of 3, 27. However, we have to subtract the non-quadratic cases, which would be um, when q of x equals 1, q of x equals 2, q of x equals 3. So these are the constants. And we also have the two linear choices, which are q of x equals 4 minus x, and q of x equals x. So 27 minus 5 equals 22. And that's B, which is the correct answer. And as a note, having so the rest of the choices are all work and they're all unique because you can think of it as polynomial interpolation, where you have three values and you can interpolate them to create, and because there's three values, you would get a quadratic, except for in these 5 cases. So the answer is B. Thank you.